So we are looking at a transistor today. What I have in my hand is a 2N3904 NPN bipolar, bijunction transistor, and it's NPN because there is a negative region, a thin base region that's positive, and then again a negative region. These are semiconductor doped to conduct negative, positive, and negative electrons or positive protons, and they are connected together to form this transistor. This little guy has three pins connected. The one is called collector, the middle region is called base, and then the last one is called emitter. So this is a symbolic representation of a transistor, and you can see that the base is connecting, or it's in the middle connecting the collector and emitter. What happens is that generally a transistor could be used as a switch, and what happens is that when there is a small voltage that is applied to the base and the emitter would start conducting, and when that happens, the current would flow from collector through the base, and it would go to the emitter. Ordinarily there is this base region would separate collector and emitter, and when a small voltage is applied to the base, this region would break down, and it would become like a conductor, act like a conductor, and it would start conducting electrons from the collector region to the emitter region. So current would start passing in this direction when there is a small voltage applied, and when a small voltage would start up flowing through this region from base to emitter, we have a large current that can flow from collector to emitter. So using this principle, it works like a solid state switch, and this could be used to create logic gates. This is the package, and on the left you have the emitter. The middle one is always the base, and towards the right you have the collector. I have a real circuit with me here. I will demonstrate that in a moment, but the circuit looks like this on a diagram. So we have a positive 5 volt, and that is connected to the transistor through a switch to the base as well, and the transistor is connected, the base of the transistor is connected to the ground or the negative 5 volt. The base is connected to two resistor, and it follows through a switch which will act as the A and B junction, or the A and B input in this case for our OR gate. And the collector is connected to a LED, and to limit the current flow through the LED we have a 1 kilo ohms resistor, and it's connected to the positive supply. So what we are trying to do is, when we switch on this one of these switches, which would act like the input to the logic gate, so the current would start flowing from this direction through this direction to the base and to the emitter. So when current flow starts flowing in this direction, this region, the base to collector, would start conducting like we saw previously. The current would now start flowing in this direction as well. So this LED should naturally come up, switch on, and show up, and we have connected two switches through the resistor, which would act like two inputs to this either or input to the transistor, and therefore it would act like a OR gate. Now let's go to the actual circuit. So we have a power supply, 5 volt supply, and it is connected to this breadboard, and in this breadboard we have these power rails on both the ends, And to the power rails, you can see that the line that is red color, marked in red color, provides a positive supply, and the one on its left is the negative supply. So the positive supply is coming to this switch. We are using these two from this 4 pin dip switch, and there are two resistors, the 10 kilo ohms resistor that is connected to the base of the transistor. So the transistor is like here, emitter, base, and collector. So the emitter is connected to the negative power rail. The base of the transistor is connected to these two resistors through the switch, and the collector is connected through the LED. And to limit the current through the LED, there is a 1 kilo ohms resistor connected to the plus 5 volt. Now this is connected, and the power is coming. So I'll try to switch on one of the dip switches. Okay, you can see that when I power on one of the input A, the LED glows. Let me try to power on B. When both the gates are on, it's still on. Let me try to switch off B. When I switch off B, still the LED is going on, powered on. When I switch off both, the LED power goes off. I'll try to switch on B input, and then the LED comes up. So the truth table works like this for this logic gate. So it would be A and B, and the output, when both are 0, the output is 0. Sorry. When either of input is 1, the output would be 1. When both inputs are 1, and the output would be 1. So that is what we are seeing here. Let me do this once again. I'll keep this to the side so that we can refer to this truth table. So A input on, both switch off, 0. Now let me try to do B input, that is B is 1, then we get 1. When both are on, then we get 1. So the idea is, through just a single transistor, we can create an OR gate, and the OR gate could be manipulated a little bit, and then through that we can create something called as NOR gate, not an OR gate. And NOR gates are very useful in creating any type of logic circuits or logic computer logics. And just by using NOR gates or NAND gates, we can create everything that is required on a computer. All possible other logic gates can be created.